in listen-only mode.
Hello, everyone, and welcome to our webinar. This is Sydney speaking, and just as in last week, we had a session on tips and tricks in 2.5D. This week, we're going to have a session on tips and tricks in HSR and HSM. Now, one of the things that the subjects that I'll actually be talking about in HSR and HSM are actually subjects that I've gotten from support calls, from looking at customers and seeing what they are missing or things they do not necessarily understand, or things they may have forgotten about that exist inside HSR and HSM. And along the way, I've also picked up some tricks every now and then. So I decided that we should have a webinar actually showing all of these options. Now, one more thing. Of course, at the end of the webinar, there will be time for questions. If you do have questions, all you have to do is click on where it says raise hand, and in the questions box, just open up the questions box, write down the question, and don't forget when you finish writing down the question to click on the send button at the end. And at the end of the webinar, I will go through all the questions and try to answer them to the best of my abilities. Okay, so let's get started. Now, the first thing I want to show you is in HSR itself. And the reason why I'm going through this particular operation is because it's relatively new and people are not really that familiar with some of the options that we have in here. So I'd like to go through the option of HSR using the roughing called HM roughing. Now, HM roughing, as I've explained in previous webinars, and we have recordings on this as well, is basically the new way that that HSR actually does the rough cuts, and it's actually divided into 3 different categories, whether it be cavities, such as this pocket inside over here, or a core, which is like this area on top over here up until that surface, or what we call HM spiral, which takes care of what's around here, where it's semi-open, semi-closed. It works well in those areas. Now, people have asked me, what if I have a part like this? Do I have to break it down into 3 different operations because it has 3 different types of HM roughing operations? And the answer is absolutely not. You do not have to. On something like this that you see on our screen, and let me show it to you, the actual answer to working on a part like this is in HM roughing is using the option of HM spiral, and we'll get through that in a moment. As you see, of course, I've chosen the option of HM roughing. We have our target, which is put in here automatically when I open up the program, so I don't have to define a target. The tool, of course, I'll use the tool that I have here, in this particular case, a 12mm end mill. And we have our constraint boundaries, just like any other HSR and HSM option. Now, let's go into passes. In passes, of course, we have our wall offset, and we have our step down. Let's have a step down of every 3mm. And we have our step over type. Excuse me. We have here, as I said, the core, which if a part was only a core area, a core area where everything was a flat floor on the outside and you just have one core sticking up in the middle, that would be perfect for that. If I had a part that was just a cavity, such as just the inside over here, it's just a pocket itself, then I'd work only using cavity. But a part like this, I can use HM spiral on the entire part itself. Let's take a look at the actual toolpath I get after, of course, I do the calculation. We'll run our calculation. Excuse me a moment. And when we look at the simulation, we'll look at it in 2 different ways. We'll look at it both at the solid verify simulation, so we can see exactly how the material is being taken off, and then we'll also look at the actual tool path itself in our HostCAD simulation. Excuse me a moment. Okay, it's the calculation is almost done over here. Okay, let's take a look now at the simulation itself. And first, let's take a look at the Solid Verify simulation. Now, we'll start the simulation itself. And as you see, first, it did the inside pocket. When it finishes that, note it starts from the outside, and it actually first cleans off the corners. Let me go a little slower. You'll see it's cleaning off the corners, and then works its way spiral around that area itself. And then this goes down all the way up until which point? Up until the point where we had that little sort of like a C-shaped area where we have that little semi-open pocket, and we'll see that in a minute. Now, when it gets to that point, all of a sudden, it starts working this. It starts working from the outside over here, and the same thing on these outside corners as well. Let's take a look at it actually right now using our HostCAD simulation so we can see the actual tool paths. We have the middle as shown over here, and then it starts working on the outside over here as well. As it goes down on the outside, and we'll take a look from the side view over here, you can see that it's going down. Taking a look at the top view, let me just clear a little, do a few more steps. You can see it cleared the outside and then worked its way spiral into the middle itself. As it continues on down, it goes further and further down on the part itself. And then it gets to this area over here where it starts working inside this area. Let me stop it, clear it, take a look from the top now. And as you can see, it clears off from the outside and then this area over here, and then clears everything out inside exactly the way it's supposed to. And this is actually a pretty efficient way of cutting the part itself. You can also see how it clears off the corners and tries to then to spiral around the part as much as it can. As far as this particular way of cutting in HM roughing, this is actually a very efficient way for using the HSR roughing. Just to show you what we used to have, or what we have in the other option, where we have the regular roughing option, I've already created an operation over here. Let me just open it up. We have the same thing, this time using the contour roughing. Take a quick look at the simulation that we have over here. You'll see that it'll do the part, but you see you have these, it comes around first on the outside and towards the inside near the part itself, it starts clearing off the corners. The other way was much more efficient in the way it cuts. Okay. Now, let's go now to this next step, which I wanted to show you. We're actually showing you some of the new things that I haven't really gone into deep before. What I'd like to show you now is something called edit passes in HSR. Now I'll open up another part over here. Okay, now we have our stock as shown over here, a regular nice piece of block of steel that we have over here. And in this particular part, I've actually, I already have one operation on it, a regular pocket operation, just to show you the simulation of the part itself, so you can see exactly how the part looks. We have our stock, and then they have the pocket that milled out the part. In other words, I'm starting off on my HSR operation with a part that looks like this. This is the actual stock that I'm going to be working on. Now, so I'll start my HSR operation. I'll choose my tool. I'll use my 20mm end mill. I'll go further down my constraint boundaries, do that automatic in my passes. I'll leave a wall offset of say 0.5 millimeters, step down every 3 millimeters, detect core areas. Now, we're going to go into edit passes. And this is what I'm talking about. Now, if I were to just calculate it the way it is now, let it cut, what's going to happen, you know what, let me just do that for a moment quickly. And what you'll see is it'll actually start working in areas where it doesn't have to work because those areas were cut already. Running my simulation, and I'll do this using Solid Verify. Let me run it slow. You can see it started cutting from the very outside. Let me actually do it a little slower. You see it's cutting on the outside, but the material over here doesn't exist anymore. So what we can do for that is go back into edit passes. Now in edit passes, if I activate it, we have an option here called stock definition style. And as it is right now, it's just looking at the target. Now, if I were to go and change this and use updated auto update stock, what will happen is it'll actually work only according to the stock that is over here, as shown over here. Now, if I were to do my calculation and then run my simulation, you'll see we'll get a completely different toolpath. It'll end up working only in the areas where it needs to cut. Taking a look at the Solid Verify now, you can see that's my material. You can see my tool now is going directly onto the material and working only in those areas, only on the material itself. There is no air cutting in this particular case. Now down here, since none of the material was taken off yet, so it did its complete cut inside over there. Now, let's take a different scenario. What would happen if I didn't have any kind of stock around this? In other words, the part I got was this part in here. In other words, the actual steel I got was this, and they told me that the stock that I have itself is exactly 7 millimeters larger on all sides. In other words, it's a mold that I got, and I have to, it's a casting that I got, and I have to machine out the casting, and the casting is exactly 7 millimeters larger than the part itself, and I didn't get any kind of casting drawing or part with it. So what can I do in those particular cases? What I can do is simple. Let's go and put this back at auto updated stock, back to target geometry, basing it on my target, and then I'll use the option of over thickness. In my over thickness, I'll tell it that we'll take my target geometry and then make it larger by 7 millimeters on all sides. Now let's run my calculation. And we'll go out of here for a moment. Of course, this pocket operation I did before, let me just suppress it because I don't need it. And let me just change my stock, because the stock that I have now is not what I had before. I just did a little bit of homework before, and I just sort of made a little bit of a stock so we can see the geometry, something that will fit exactly what I need. Let's run my simulation, and we'll use Solid Verify. And you'll see now that the tool will work exactly. Whoops, my mistake. My passes, I forgot to say, my passes is 7.5. Okay, I said 7.5 millimeters above the top as well. Now let's do our calculation. And I saw that because of the crash, which is why we have simulation. Now let's run my simulation using Solid Verify. And what you'll see is very simple. It's working only with this material, exactly 7 millimeters. Now, it didn't see the material because there was no material over here, really. I just brought this in at my stock. But all I did was tell it that it was 7 millimeters larger on all sides, and it machines exactly in those areas. Let me just run the simulation one more time, this time using the host CAD so you can see actually where the tool passes exactly are. If you take a look now at the simulation, it's working exactly around the part about 7 millimeters away only. This area over here has no machining at all. And if I actually zoom it in, since I said 7 millimeters, so that leaves me about 3 steps that has to be done over here. And you can see 3 tool passes on this level over here and working around the exact part. Now, let's continue on. And I'd like to go now into my rest rough operation and show you something, an option that we have over there called minimum profile offset, minimum profile diameter, and show you exactly how that works. I'll go into this operation I just did and just do save and copy. And instead of contour roughing, I'm going to use the option of rest roughing now. The tool, of course, will be a smaller end mill. This time I'm using a 12 millimeter end mill with a 2 millimeter radius at the bottom. In other words, the bottom diameter of the tool itself is actually only 8 millimeters. I'll select my tool. We have the same boundaries, passes. We'll have a step down of every 2 millimeters, and we'll run my calculation, and in a moment we'll run my simulation. Now, I want you to pay attention to what's actually happening. There are 4 holes in this part itself, and we'll see that in a minute as soon as it finishes the calculation. Let's run our simulation. You can see that there are 4 holes over here. Now, these holes themselves are 21 millimeters in diameter. So if we added another 0.5 millimeter for the offset all around, that makes, in other words, this is actually 20 millimeters in diameter of wherever it has to work. And the tool itself is 12 millimeters. Now note, when I run the simulation, you'll see it'll do its simulation as it does over here. But when it gets down to this floor over here, let's see what happens with the tool. Will it go in or will it not go into the hole? And that's the big question. I know the answer, but we'll see exactly what's going to happen. And then we'll talk about in a moment why that happens. Okay? As it gets down to the very bottom, clearing out that area over there. Now, in a moment, it's going to get up to the area that I was talking about. Let it finish over here as well. Sorry, my mistake. It didn't do what I wanted to do. I forgot to reset something. Rest roughing, 12 passes. Now, you notice, by the way, that the tool did not go into the hole when I did my simulation. The reason for that is for my minimum profile diameter. Let me reset this exactly the way it's supposed to be. Rerun my calculation. And again, you'll note, this time I'll run my regular simulation. You'll see that the tool will not go into these holes. Why is that? Very simple. Because what this parameter does, in my link, what the minimum profile diameter does is as follows. It has the diameter of the tool is 12 millimeters, as I said. This here is a value of 8.8. 8.8 and 12, if you put that together, is 20.8. The whole area that it has to clear over there is a total of only 20 millimeters. Remember, we have an offset of a 0.5 millimeter, so we only have 20 millimeters. So this area is actually larger than this area over here. The 8.8 together with the tool comes out larger than the area of the hole itself. Therefore, it won't go in there. Let's just take a quick look at this little diagram that I have over here. And what you can see is as follows. We have our diameter as shown over here. We have our offset. And here we have our tool. We have our tool diameter. We also have a tool flat diameter. You can see this area here, this distance here is the actual minimum profile diameter distance. If this distance actually goes into the circle itself as it does over here, then there's no room for the tool to go down. If I do want the tool to go down, what I can do is very simple. Let's actually make my minimum profile diameter. Let's have it at 5 millimeters. Let's run my simulation now after I do my calculation, and let's see what happens now when I do that. This time what you'll see is the tool is actually going into the circle itself. So basically I can use this to stuff up holes if needed, just by making my minimum profile diameter large enough that the tool will not go in there. Okay? That's exactly what you can use the minimum profile diameter for. Now, let me load one more part, and I want to show you something called using approach points in our roughing operations. I'll load a new part. A simple box, because it's very easy to show it on this part itself. And what I'd like to do is an HSM operation, HSR operation over here. Let me just delete what I did before. And what I like to do, however, is before I do the operation, I like to actually drill a hole in here, or holes in here, so that the tool will go into the holes itself instead of ramping in. So I have an operation over here where I have the drills. And actually I'm going to use a different operation that I have over here, where we have two drill points over here. One over here and one over here. The tool that I will be using will be a 60 millimeter drill, and the depth I want to go up to is this surface over there. Now, in my technology, fine, everything's great. Let's run my simulation, and you'll see that by running Solid Verify, we have our two holes over there. Now let's run our HSR operation. I'll start the HSR operation, choose my tool. Let me choose a 12 millimeter end mill. We have a constraint boundaries, our passes. Let's go now to our links. Let's actually go back to our passes and change my step down to every 10 millimeters. And let's go now into our links. In our links, we have what we call ramping, how we're actually going to ramp into the part itself. Excuse me. Now, we also have an option called use approach points. By using the approach points, this allows me to go into this field over here and choose the actual drill points that I created over there. So it will actually go into the part through those drill points itself. Let's actually do the calculation and run the simulation. Solid Verify, we can see our two holes over there. And as you can see, I'll do this one step at a time in the very beginning. The tool goes directly into the hole, as shown over here, and then clears out the two pockets at the bottom. Now, why did I make two drill holes? Why not only one drill hole? Actually, I could have. But there are certain rules you should know about drill holes. And that's as follows. If I were to create an operation using only one drill hole, and let me do that actually over here. I'll change it to my first geometry over here, which will give me only one drill hole. In this particular case, I did it right down the middle. When I do my operation of HSR, and this time in my links, by my ramping area, I'll use the one I have now, that one hole. You'll see it'll go into that, but note what happens at the pockets, in the pockets at the very bottom. We'll run my Solid Verify. It goes in as I showed you, but note, actually let me do this again. As you see, it goes right into that hole. Note, however, those two pockets we had on the bottom were not machined. When using the option of use approach points, it'll only machine out the areas that can use those points itself. In other words, those deeper pockets, since they're deeper than this hole itself, it cannot use this hole to go in there. It will not machine out those pockets itself. And the reason for that, the way this is made, is that it's taken into consideration that most of the time people want to use this is when they have end mills that cannot cut at the bottom of the end mill itself. So they need some kind of a lead hole. So in this particular case, if they have that kind of a end mill, in these areas over here, it cannot go in by your way we normally go in an HSM, so therefore it did not work in those areas. This is why I created the two holes instead. Okay, let's go into our next part, and now we'll start showing you options in HSM. First, I'd like to show you the first thing I'd like to show you in HSM is actually just a little bit of a actually a cutout part. I just want to show you something that we have over here. And let me just delete the operations that I have over here. Okay. What I'd like to do is do a linear cut going back and forth. And I'll show you the reason why. Now, when I do a linear cut on this, I'll use, of course, the 3D HSM, use the option of, excuse me, linear machining, and I'll use my tool, and we'll also use my constraint boundaries and my passes, and I'll have my passes go step over every millimeter. Okay, we'll run our simulation, and what's going to happen is the tool, let's run it actually using the side view, the tool will work exactly the way I want it, but note that it goes into this area over here. Now, what I'd like to actually do is I really don't want it to go into this area at all. I'd actually like to go directly over to the next side. Now, one thing I could do is I can define a different type of geometry. My boundary. I can define a different type of boundary, but let's say I don't want to change my boundary for whatever reason. Okay, I just want to not go into that area. Well, there's a little trick we can do over here, and I can use the option in geometry of apply fillets. Now, most people know about the option of apply fillet with basic. Let's use the option of apply fillet instead of basic. Let's go to advanced. And when I go to advanced, we'll make a definition, and we'll do the following. I'm going to actually create a tool that has a 20 millimeter diameter, but the corner radius is going to be like a bullnose, only 5 millimeters. Actually, you know what? Let me make this 25 millimeter radius tool with a 5 millimeter corner radius. If I were to calculate it and show what kind of a fillet is actually going to build for me over here, it's going to do something like this. Picture a tool that's 25 millimeters in diameter with a 5 millimeter bullnose. That's exactly what you're going to get over here. And this is the kind of surface it builds for me over here. So using that now, doing save and calculate, we'll see now that the tool pass will not go into those areas at all. It'll skip directly over that area because it's looking at it as if there is some kind of a fillet over here, some kind of a material over here that it can't go in there. So just by using the option of advanced in applied fillet and using a tool that's larger in its area and a corner radius, you can actually just clog up that slot over there very easily without having to create a new type of boundary for the part itself. Now let's continue on one more area in linear on this part itself, and that's passes. People have asked me many times, okay, I have my step over, I understand that. But what does step down mean? Well, step down is very simple. Right now, it shows 50 millimeters. 50 millimeters is all the way to the very bottom of the part itself. Now, what does that mean? It means it'll continue going down on the part until it goes down as far as it can. And if that's 50 millimeters, 50 millimeters, it'll be 50 millimeters. In this particular case, it's less. And then go across exactly the way we know it to work. But what if I want to actually do it in steps? Well, let's change this to every 5 millimeters, a step down of every 5 millimeters. And let's take a look exactly what happens in our tool pass. Simulate. Let's take a look now using the side view in our simulation. You'll see this time the tool goes down only at 5 millimeters that I put it over there. Now, when it finishes that, let's just take a look now at this view over here. You can see actually what's going on over there. Let it finish. I'll clear it away. And then we'll see what will happen with our next step. Okay, almost done. Now, let me clear this away and continue on with the simulation. You note, it's continuing from this area down, and then just going down every single time even more until it gets to the very bottom, going down every 5 millimeters, the way I wanted it to go down in this particular case. So if you want to control how far down it goes each time, instead of doing one entire step the whole time, this can be done just by changing the step down inside linear. Okay, now let's go on to our next part. I'll open another part. Okay. Okay, let me erase what I've done over here before, and we'll start new. The mold that we see over here on our screen, if we want to do a finish cut on this, let's take a look at the walls themselves. The walls are actually angled, have a pretty steep angle, whereas these floors over here actually have a pretty shallow angle, and these are actually also pretty shallow over here as well. And I've seen a lot of people still using the option, two different operations, where they would first do a constant Z, because constant Z actually works beautifully on these steep areas, but does not work well on shallow areas. Whereas linear operation works beautifully on the shallow areas, but does not work well on steep areas. So what I've seen people do is actually use two different operations, one constant Z and one for and one linear. Linear for the shallow, constant Z for the steep areas. What we can do is very simple. If I were to go into my HSM operation, use the option of combine, excuse me a minute, a little bit lingering from the cold I had last week, combine constant Z with linear. In other words, doing two operations within one operation. Okay, now, excuse me, let me take my tool. I'm going to use a 12 millimeter ball and mill. And we have our boundaries, and we have our constant Z passes. In our constant Z passes, let's just leave our step down exactly the way it is. But as I said, the constant Z works well in steep areas. Anything above, let's say, 45 degrees, it really doesn't work as nicely. So what we're going to do is anything below, let's say, 40 or 35 degrees doesn't work that nicely. So what we're going to do is we're going to limit our working area on the angle of the part anywhere between 40 and 90 degrees. Those are the only areas where I want my constant Z to work. Okay, now let's just go into our links. Just for now, I'm just going to change it to bidirectional. Now we have our constant Z, as I said, remember 40 to 90. Now let's go to our linear passes. In our linear pass, if we take a look at the angle was automatically put between 0 and 43 degrees. In other words, this is a 3-degree overlap between the constant Z passes. And the linear works well over here in the shallow areas, which is exactly where this is going to work now. Just to show you that this actually changes according to what I have over here, if I were to go into this area, angle, and make this 35, go back into my linear passes, you'll see now that this has changed to 38. Okay, let me put this back at 40. You can see my linear passes now at 43. And we'll just have a step over of every millimeter and run my calculation and then my simulation. Okay, let's run the simulation itself. And we'll just look at the tool path right now. I'm not looking for the solid verify. And you can see the constant Z working nicely on these areas over there. And then working on the flatter areas, on the shallower areas, using the option of linear on the part itself. And this is actually probably the best way to do this. Now, however, let's take one more look in these areas over here in the corners. I used a pretty large end mill, a 12 millimeter ball end mill. Now, this radius over here is actually smaller than the ball end mill. Note, because of that, we have a sharp turn as it goes from this wall then onto that wall. Having a sharp turn over there can sometimes leave marks or dimples, as you may say, on the wall itself. So what I'd like to do here is actually have a fillet that's larger than the tool itself. So let's go back into our operation and go into geometry. This time I'm going to use applied fillet, but this time I'll just use the basic. Before I use the advanced, in this particular case, basic is enough. Since I'm using a tool that's a 12 millimeter ball end mill, in my applied fillets, I'll use something that's a touch bigger, something like 13 millimeters. And what that is going to do is actually going to build a fillet of 6.5 millimeters in that area. Thereby the tool will roll on that corner instead of cut into the corner itself. Let's just do our calculation and simulation. We'll take a quick look at the at the corner itself to see exactly what happens. Excuse me. Okay, as we take a look at the simulation when it gets to this corner itself, in a moment it'll get there. You can see now as I zoom in, now we have a little bit of a radius in that corner over there, instead of that sharp turn that we had before. Okay, now, what we still have to do, however, is we have to finish off those corners. So for finishing off the corners, we have an option that we all know called rest machining. Now let me open up a new operation of rest machining. Now, one thing when you do rest machining, as shown over here, remember you do not use applied fillet, because if you leave the applied fillets, the rest machining works on the fillets that's over there. So it's not going to do much for you. Now, what exactly do I want to do over here? I want to actually clean away all the areas that were left on by the fillets. Now, over here I have larger fillets, and over here I have smaller fillets, as well as over here. Now, I don't want to work with my smallest fillet end mill on everything, because that would only, one, take a long time, two, that small tool is taking off a lot of material, and I'll be lucky to have a tool left at the very end. So that's not the best way to work. So first I'm going to start off using a larger ball end mill. So I'll use I'll start off by using a 8mm ball end mill. And in my reference tool, I'll have my reference tool at 13mm, which was my my applied fillet radius that I had before. Let's just go into my passes, leave my step down at every millimeter, run my calculation. Now, the idea behind this is to show you can gradually bring down that extra material on the radius just by going down every single time with a smaller ball end mill. And the first one over here, as you're being shown, is the 8mm ball end mill. Excuse me. Let's just finish. Okay. And as you can see, let me actually show you the entire part. The ball end mill works in all of the areas, but in these areas over here and these areas over here, there's still material that has to be taken off. In this area, there was nothing left to be taken off because this area was larger than the 6.5mm radius. But these areas over here had to be taken off. So now let's go and take it further down. I'll do save and copy. This time I'll use now a smaller end mill, a 6mm ball end mill. And as far as my reference tool, I'll change that to what the tool I used before, and then 4mm ball, my 8mm ball end mill. Let's run my simulation now. Of course, we have to calculate it first. Running the simulation, you'll see that this time it will not work in all the areas. This area was finished by the previous tool. Now it's only working in these areas over here. But I still have to go down further. Now, the next tool I'm going to use, I know that I have a 2mm radius over there. So actually, I'm going to use a 3mm ball end mill. Now, had I used the 3mm in the very beginning, I would have broken the tool. So this is exactly why we do it in steps. I'll use now my last end mill, my ball nose end mill of 3mm. Reference tool this time will be the 6mm end mill. Let's just go into my passes. Let's do smaller steps every 0.5 millimeter. Run my simulation. Of course, calculate first, as you see. And as you'll see this time, it'll work only where it needs to work, where they have material left over to be cut. Okay, so these areas didn't work anymore. It just worked in these small areas around over there. So gradually, I brought down my rest roughing. I didn't do it all with one small tool. I did it gradually as it went down. Okay, that's basically it. Now let me just go through any questions you may have. And first question I see here is, can you have approach points positioned outside the part? And do they have to be drilled holes? The first part of that question is, the approach points from the outside. Can you have approach points positioned outside the part? No, you can't, because if it does it outside the part, it'll recognize that it's from the outside of the part, and you don't need. It doesn't work on from the outside of the part with the approach points, only from inside the part itself. Now, do they have to be drilled holes? No, they don't have to be drilled holes. They can be already existing holes. All you have to do is create a point in the center of that and just define it itself. I can go, let me just reopen that part itself. Here we go. What you're saying is, if I didn't have a drill at all there, so I'll just suppress that for a moment. What if I, as if I already had a hole in this area, so I don't want to drill the hole. All I have to do is go into my operation over here. In my links where I have the ramping, I can create a point. I'll create a point over there. And what it'll do, it'll go into that point. Now, obviously, in this particular case now, I have full material over there because I didn't do the drill like as if there was a drill there. But you'll see that the tool itself, and I'll do this one step at a time, will go in directly into the middle of the part. That is, of course, if you have a hole over there. Even though I didn't create a hole over there, all I did was create a drill point. And that was done within the operation itself. So the question to that is, I do not have to drill a hole there beforehand. Okay. Is it any possible to download models used in this webinar? Yes, the parts will be available. If I were to go into my website, I'll actually show you exactly where we have that in our website. You can, in our website, which is my mistake. Oh yeah, okay, over here. If we go into webinars, webinar recordings, at one point tomorrow, this webinar will come up, but these webinars that we have over here, at least from the last month or 2 months, I believe, we have the option of downloading the actual video instead of just viewing it over here. And over here, we also allow you to download the parts used in the webinar. So tomorrow, when we'll have this webinar already posted in this area, you'll be able to download it from this area itself. Okay, I'd like to thank everyone for joining our webinar, and see you again in our next webinar. Take care and have a great day.